Okay, this is a finance problem. So let's try to figure out what exactly we're dealing with here. You want to be able to you want to be able to withdraw $30,000 from your account each year. I'm going to triple underline that because this means annuity. All right, so we're doing that for 25 years after you retire. You expect to retire in 15 years. If your account earns 6% interest, how much will you need to deposit each year until retirement to achieve your retirement goals? Um, yeah, and then it kind of tells you that you need to use both the annuity formulas. We're going to start with the first part, because you want to be able to take 30,000 out each year. So that's a payout annuity. So we can use the payout annuity formula. P sub 0 equals 30,000. Parentheses 1 minus, parentheses 1 plus. The interest rate is 6%. So 0.06. And it's for each year, so divided by 1, close parentheses to the negative. We have two different years given here, but the $30,000 goes with the 25 years. So 25 times 1. And close the parentheses there, and that's all over 0.06 divided by 1. All right, I don't know what that is, so I'm going to use Desmos over here to help me. I start with the fraction button. 30,000, parentheses 1 minus 1, parentheses 1 plus 0.06 divided by 1, close parentheses, raise to the parentheses negative 25 times 1, close parentheses, and then the bottom 0.06 divided by 1. So in order to be able to withdraw 30,000 each month, you're going to have $383,000. $383,568. Let me try that again. $383,500.68. I was trying to write it and say it at the same time, which I was failing at. All right, for the second part, now we need to figure out, this isn't even the answer, but we need this to be able to do the second part. So the second part is saying how much we need to deposit each year. So that's talking about a savings annuity. Savings annuity is P sub 0, P sub n. But instead of P sub n, I'm going to put what we just found, because that's what we need to have. 3,083 or $383,500.68. Back. Okay, I'm gonna squeeze a 68 in there. Equals D is what we're trying to find, and then we draw the big parentheses. And we have a fraction on top. It's going to be parentheses 1 plus the interest rate, which is still 6%. We're still looking at 1 time per year, so over 1. Close parentheses. And that now it's 15 years. We have 15 years to save up. So 15 times 1 minus 1 on top. And then 0.06 divided by 1 in the bottom. And we need to figure out what everything except, we can put everything except D into Desmos. So I'm going to do that. I'll hit enter here. Fraction, parentheses, 1 plus 0.06 over 1. Close the parentheses. Exponent parentheses 15 times 1 minus 1. And then click into the denominator to do 0.06 divided by 1. So everything in those giant parentheses is equal to about 23. So in order to find D, I need to divide both sides by that. So I don't want to write all of that out again. I'm just going to say divided by 23. You could put 23.3. It doesn't matter what you write on your paper. We're just going to be careful not to round until the end in the calculator. All right, I'm going to hit enter here. Gotta get over there. And now I want to divide all of this. So I'll just copy and paste this. You could type it in. And then I'm dividing that by what we just got. So A and S to put everything, all the digits for the answer we just got. So we're not rounding until the very end. Now I can round that I have my answer. The deposits are going to have to be $16,476.25 every year for 15 years in order to reach that goal of having $30,000 withdrawn every year for 25 years. So it's a two-part problem. You have to use both annuity formulas. Use P sub 0 first, then P sub n, and then you have your answer. So I hope that helps. And that's it.